MicroUSB. The micro-USB connector was the dominant standard for mobile devices, tablets, and portable electronics for over a decade. Introduced in 2007 by the USB Implementers Forum, it was designed to be a thinner, more durable replacement for the older mini USB. While it has now been largely superseded by the reversible USB-C, millions of devices, including older smartphones, Kindles, Bluetooth speakers, and DIY electronics like the Raspberry Pi, still rely on this interface. For a technician, microUSB represents a significant era of standardization that finally ended the proprietary charger chaos for mobile phones. Physical design and durability. The microUSB connector is roughly half the thickness of the mini USB. It features a distinct trapezoidal shape, which acts as a physical key to prevent the user from inserting the cable upside down. Unlike the earlier mini USB, which relied on the friction of the metal housing to stay connected, the micro-USB utilizes two small spring-loaded hooks, latches, on the bottom of the plug. These latches are a critical piece of engineering. They were designed to move the wear and tear from the expensive device, the phone, to the cheap cable. In the mini USB era, the jack on the device often became loose over time. With micro-USB, if the connection becomes unstable, it is usually because the small hooks on the cable have worn down, and simply replacing the cable fixes the issue. The connector is rated for 10,000 insertion cycles, making it much more robust for daily charging than previous standards. Data and power capabilities. Technically, the most common version of this connector is the MicroB. It features a 5-pin layout. Pin 1, power positive 5 volts. Pin 2, data minus. Pin 3, data plus. Pin 4, ID identification. Pin 5, ground. Under the USB 2 high-speed specification, microUSB supports data transfer rates up to 480 megabits per second. In terms of power, a standard microUSB port is typically rated for 500 milliamperes, but with the advent of fast charging and dedicated wall chargers, many ports can handle up to 2 amperes to charge large tablet batteries. The 5th pin and USB on the go, OTG. One of the most powerful features of microUSB is the ID pin, pin 4. In a standard charging cable, this pin is not connected. However, when using a USB on-the-go (OTG) adapter, this pin is physically connected to the ground pin. This signals to the device, like a smartphone, that it should switch from being a peripheral to being a host. This allows a user to plug a USB thumb drive, a keyboard, or even a mouse directly into their phone or tablet. For a technician, an OTG adapter is an essential tool for data recovery. If a phone screen is broken and the touch interface doesn't work, plugging in a USB mouse via an OTG adapter often allows you to navigate the menus and back up the user's files. The USB 3 double-wide MicroB. When the industry transitioned to USB 3, the standard 5-pin microUSB didn't have enough wires to handle the 5 gigabit superspeed data. To solve this without breaking backward compatibility, engineers created a double-wide version of the microUSB connector. It looks like a standard MicroB plug with a second, smaller connector fused to the side. This extra section contains the 5 additional pins needed for superspeed transmission. This connector is very common on portable external hard drives. A clever detail of this design is that you can still plug a standard, single-wide USB 2 microUSB cable into the larger side of the port, and the drive will still work, though it will be limited to slower 2 speeds. Troubleshooting and common failures. The most frequent issue with microUSB is debris contamination. Because the port is often carried in pockets, it can collect lint and dust. Over time, this debris gets packed into the back of the port, preventing the cable from clicking into place. A technician should always use a non-conductive pick and compressed air to clean the port before declaring it broken. Another common failure is the upside-down force damage. Because the trapezoidal shape is subtle, Many users accidentally try to force the cable in upside down, which can snap the internal plastic tongue that holds the copper pins. If the port feels mushy or the pins inside are visibly bent, the entire jack must be desoldered and replaced.